Hello, I'm Ms. Troyer, and today we're going to learn about adding and subtracting fractions by finding what's called a common denominator. So, can you both tell me what you know about fractions? Someone? Nick?
I know that we learned how to add them last week, so I know how to add fractions.
Okay.
Yeah, and there's a top number and a bottom number in a fraction.
Okay.
Yeah, and you add the top number.
So, if we have this fraction, these two fractions, does someone know how to add these two fractions together?
Yes.
Okay.
1 plus 1.
How do we do that?
1 plus 1 is 2.
So where does the 2 go? On the top?
Yeah.
And what is the bottom number going to be?
2.
2. Good job. Okay. Now, these fractions have the two bottom numbers in common. What are those two bottom numbers called?
2.
What are they called? Emily?
What we're learning today, the common denominator.
They're called denominators.
Yeah.
And they're the same, so they are common denominators. Now, if we have two fractions like this, can we use our same method of adding these two numbers?
I'm not sure.
The answer is no. Because we do not have a common denominator. And here's why we can't do that. Let's say we have 3 dogs plus 2 cats. Can we say that our answer is 5 dogs?
No.
No. Can we say that our answer is 5 cats?
No. There's 2 cats.
There's 2 cats and there's 3 dogs. So, what we need to do is find a common denominator for these objects. So, what could we label these cats and dogs as? What kind of category would these fit under, besides dogs or cats?
Good pets.
Good pets. And how many good pets do we have? 5 good pets. Now, when we have fractions, we're gonna do the same thing by finding a common denominator. So what we need to do is find a number that these two numbers have in common. So something that can evenly go into these two numbers. So we're going to use our pattern blocks. And we're going to pretend that 2 of these represents 1 whole. So that makes one of these 1/2. This is 1 whole. So now what we want to do is find out which one of these shapes fits into gonna have to pause it.
Okay. Good stuff.
So, what we're gonna do is we're gonna imagine that this represents 1/4 and this represents 1/6. And we have to find which of these shapes can fit into both the 4ths and the 6ths. So, working teams to figure out which shape can fit into both.
It's fine. Triangle!
I think it's trying.
You both agree that it's a triangle?
I think so.
Okay, so if two of these represents a hole,
Mm-hmm.
what does the triangle represent?
Can I test
How many triangles can fit in there?
Can I test it?
Yes.
Okay.
I mean, no. 12.
12! Good job. So, fourths and sixths have 12 in common. So, what we're going to want to do is change our denominator to 12. And how can we do that? And this number, what do we need to do to the 6 to make 12?
Do 2 double.
And would we also have to do the same thing to the 3?
Yeah.
Yeah. Now, Nick, why do we need to do the same thing to the 3?
Because they come in pairs.
We come in pairs.
One doesn't
Or-
do one without the other.
Or because if we don't, then we're gonna have 3 12s. And is 3 12s equal to 3 6? No. Which fraction is bigger?
3/6.
3 6 is bigger. So these fractions are not equal. But if we do the same thing to the top fraction, the answer will be equal. So now we have, what's 3 times 2?
6.
6. 6 times 2?
12.
12. For our second fraction. And for our first fraction, what do we need to do to this 4 to get 12?
3 times by 3.
Times it by 3. And what do we need to do to the top number?
Same.
The same thing.
Base.
So now what do we have? How many 12s?
9.
9 12s. Okay.
Okay.
So now we have 9 12s plus 6 12s. What do we need to do to find the answer to this fraction?
Now we can add just the top, right?
Yeah. So can you do that for me?
15. I did it on my fingers.
Wow, Nick. I'm proud.
I used my toes.
We now have 15 12s. And that is our answer. And we have successfully found the common denominator. Good job, class.
What about 1 and 3/12? It would be 1 and 4.